One of the greatest scientific missions of modern times has taken a giant leap forward today with the launch at lunchtime of the James Webb Space Telescope. A $10 billion project has taken 30 years to reach this moment. The telescope was launched from Kourou in French Guiana. It's the most powerful ever built, and developers hope it will reveal stars and galaxies from the birth of the universe.
The observable universe, a staggering 93 billion light-years wide, is merely the known tip of an unfathomable, unseen cosmic expanse. However, the James Webb Telescope has found the edge of the observable universe. Could this discovery rewrite the story of the cosmos or reveal something we're not ready to face? The universe's enormous scale. Neil deGrasse Tyson once said, "The universe is not only bigger than we can imagine, under most scales, it is bigger than we can imagine." These words perfectly capture how humans struggle to understand the true size of the universe. We look up at the night sky and see stars. But the vastness of what is out there goes beyond what we can picture. For centuries, we have tried to measure the universe and figure out where it begins and where it ends. But with every discovery, we find that it's even bigger and stranger than we thought. The question of whether the universe has an edge or a starting point is one of the greatest mysteries in science. And now the James Webb Space Telescope is giving us clues that might finally help answer these questions. Hundreds of years ago, people believed that Earth was the center of everything. The stars and planets were thought to move around our world, and that was all there was. But then came groundbreaking discoveries. Copernicus showed us that Earth is just one of many planets orbiting the Sun, which is only one of billions of stars in our galaxy, the Milky Way. This was a huge step forward, but it only made us realize how small we really are. The Milky Way is just one of billions of galaxies, each with millions or billions of stars. Our understanding of the universe grew, but with that growth came even bigger questions. Is there an end to the universe? What's beyond that edge? Or is it infinite with no limit at all? The James Webb Space Telescope, launched in December 2021, has given us more answers and even more questions. This powerful telescope was made to look deeper into space than ever before. Unlike the Hubble Space Telescope, which sees invisible light, the James Webb Telescope sees in infrared. This allows it to look back in time to when the universe was very young, just a few 100 million years after the Big Bang. It's like peering into the past, seeing the birth of stars, galaxies, and the very building blocks of everything we know. The James Webb Space Telescope is revealing the universe like never before. Our planets, the furthest galaxies, and the strangest phenomena. And what you can see is actually material falling into a black hole. And that's only in the first few weeks. One of the most surprising findings from the James Webb Telescope is that it has spotted galaxies that are older and more developed than we expected. These galaxies appeared only a short time after the Big Bang, much earlier than scientists thought was possible. This discovery makes us question everything we believed about the early universe. How did these mature galaxies form so quickly? What unknown factors were at work? This is a game changer, forcing scientists to rethink how galaxies and stars were made. It shows us that the universe is even more mysterious than we realize. But what about the idea of an edge or an end? If we try to imagine what the edge of the universe would look like, we run into a problem. The universe is not standing still, it is expanding, getting bigger every moment. This means that when we look out into space, we are not just seeing faraway stars and galaxies. We are also looking back in time. The light from these galaxies took billions of years to reach us. This is why we can see them as they were billions of years ago. So when we look for an edge, we have to remember that it might be moving away from us faster than we can imagine. The search for the edge of the universe is like trying to find the walls of a dark, never-ending room. Imagine standing in a concert hall where you can only see a few tiny lights, but you don't know how big the room is. You try to move forward to find the walls, but as you move, the room itself is getting bigger. This is what it's like to search for the edge of the universe. Even as we get better at seeing farther with the James Webb Telescope, the universe keeps expanding, making it impossible to find a true end. And because we see everything in the past, we may never know what's really out there now, far beyond what we can see. The James Webb Telescope has given us more than just distant galaxies to study. It has also found evidence that the universe is not expanding at the same speed everywhere. This could mean that the universe is not just one simple, uniform space. Instead, it may be made up of areas that expand at different rates or have different structures. This challenges our ideas of what the universe should be and makes us wonder if there are other dimensions or areas of space that we haven't even thought about. One of the most incredible discoveries from the James Webb Telescope is the finding of a quasar at the center of a young galaxy. This galaxy, formed just about 570 million years after the Big Bang, has a black hole that is 10 times the mass of our Sun. The black hole's energy is so powerful that it makes the galaxy shine brighter than anything else we've seen. This kind of discovery shows that even in the early universe, there were already forces at work that we didn't expect. It proves that our understanding of cosmic history is far from complete, and there is still so much more to learn. Another surprising find is the discovery of a giant gas planet called HIP 65426b. This planet is about 12 times larger than Jupiter and orbits its star at a distance far greater than Pluto's distance from the Sun. Thanks to the James Webb Telescope's new technology, we were able to see this planet directly for the first time. Most exoplanets are discovered using indirect methods, so seeing one clearly is a rare event. This shows that even in the search for distant planets, the James Webb Telescope is breaking barriers and showing us things we never thought possible. The James Webb Telescope represents an extraordinary feat of modern engineering, combining cutting-edge technologies unprecedented in human history. From its advanced launch vehicle and sophisticated image processing to intricate electromechanical systems, innovative cooling mechanisms, a segmented mirror, and a vast sun shield, every component is a testament to human ingenuity and technological progress. These discoveries remind us that the universe is not just a collection of stars, planets, and galaxies. It is full of strange and powerful phenomena, new discoveries, and endless possibilities. It pushes our minds and our technology to their limits and shows us that there is so much we still don't know. The more we learn, the more we realize how little we truly understand. With the James Webb Space Telescope revealing new, astonishing insights, could it be that our understanding of the universe's birth is only scratching the surface of a much deeper, more complex story? To the Big Bang. The story of how the universe came into being is one that has fascinated people for thousands of years. For much of modern history, the Big Bang theory was our best explanation. It described an event where everything started from a single tiny point, a singularity, exploding and expanding into the vast universe we see today. The Big Bang theory suggests the universe began as an infinitely dense, hot point, just a few millimeters wide, like a supercharged black hole. Around 13.7 billion years ago, this singularity exploded violently, creating all matter, energy, space, and time. This explosive event marks the birth of our universe. This theory has shaped our understanding of space, time, and our place in the cosmos. But now, with the arrival of the James Webb Space Telescope, that story is being rewritten. The telescope's incredible ability to see the oldest and most distant corners of the universe has revealed astonishing new truths that challenge everything we thought we knew. Before the James Webb Space Telescope, we had hints of what the early universe might have looked like. It sees the light that has traveled for more than 13 billion years, letting us look at the universe as it was only a few hundred million years after its birth. What the James Webb Space Telescope has shown us so far is nothing short of revolutionary. The telescope has found galaxies that appear fully developed, with complex structures and bright centers, when they should have still been in their infancy. These findings are shocking. The galaxies that have been discovered don't match the expectations of scientists who believed that the universe took its time to evolve, growing slowly from simple clouds of gas into the beautiful, star-filled galaxies we see today. Instead, the James Webb Space Telescope has unveiled galaxies that seem far more mature and advanced than they should be for their age. How is it possible for a galaxy to be so well-formed so soon after the Big Bang? The answer could change our entire understanding of cosmic history. The discovery of these mature galaxies raises questions that go far beyond the capabilities of our old theories. It's as if the universe is saying, "You thought you knew the story? Think again." Scientists are now left scrambling to find explanations. Was there a faster process of galaxy formation than we thought? Could there have been cosmic events or conditions that allowed for more rapid growth? Perhaps the James Webb Telescope has shown us that the universe has secrets we haven't yet discovered, ones that could reshape how we think about the birth of galaxies and stars. One of the biggest mysteries these findings bring to light is the role of dark matter. Dark matter is a type of matter that we know exists because of its gravitational effects on visible matter. But we can't see it directly. It makes up most of the mass in the universe, yet we know so little about it. Could dark matter have played a role in the creation of these ancient galaxies? Could it have accelerated the formation of stars and galaxies in ways we never imagined? James Webb Space Telescope's discoveries suggest that dark matter might be more influential in the early stages of the universe than we've given it credit for. These changes in thought also lead to deeper questions about the nature of the universe itself. If galaxies could form so rapidly, what does that say about the forces at work in the early cosmos? Did some unknown process speed up the growth of matter, creating more complex structures than we thought possible? James Webb Space Telescope is forcing scientists to rethink their theories and consider that the universe's story might have hidden chapters we've never read before. The idea that galaxies could have formed so quickly also raises questions about the types of energy and conditions that were present in the first moments after the Big Bang. Was there a burst of activity or a series of events that pushed the universe into a more complex state far sooner than we realized? The discoveries made by the James Webb Telescope are so profound that they challenge not just the details of cosmic history, but the very methods scientists use to study the universe. Observing these ancient, faraway galaxies requires thinking in new ways. It means accepting that what we see might not be what we expect, and that the universe could be more unpredictable and chaotic than we ever imagined. It reminds us that science is not a set of unchanging facts, but a living, breathing search for understanding. With every new image and piece of data the James Webb Telescope sends back, we are faced with the humbling realization that we know less than we thought. So what does this mean for the future? Each revelation pushes us further to ask deeper questions. If galaxies could form so quickly, what about the formation of black holes, stars, and other cosmic structures? Are there more unknown processes or hidden laws of physics that could explain these findings? James Webb Telescope is urging us to go beyond our current ideas and reach for new ways of thinking. It shows that the story of the universe is far more complicated and wondrous than we've dared to imagine. The birth of the universe, which once seemed like a simple tale of expansion, is turning out to be an epic saga with twists and turns that we are only now beginning to understand. While the James Webb Space Telescope continues to redefine our understanding of cosmic birth, it also compels us to rethink the very nature of space, time, and existence. Are we truly prepared for the vast and mysterious answers it promises to reveal? Our understanding of space, time, and existence. James Webb Telescope's groundbreaking observations have opened a window into realms we never thought possible, challenging our fundamental beliefs about space, time, and what lies beyond. It has revealed that the universe is far more complex, vast, and mysterious than we ever dared imagine. James Webb Telescope's ability to peer into the distant past has shown us that space is not just a stagnant backdrop, but a dynamic, ever-changing entity. This means we are not just looking at stars and planets, we are observing the very fabric of space itself, stretching and shifting as the universe evolves. The realization that space is not fixed, but is instead moving, growing, and expanding is an idea that pushes the limits of human comprehension. It leads us to question, if space can change, then what are its true boundaries? Can we even grasp the idea of infinite space, where every observation uncovers more questions than answers? One of the most awe-inspiring revelations is how it has shifted our understanding of cosmic movement. When we look at distant objects, we see them not as they are now, but as they were when their light first left them. This means that the universe is not just vast in distance, it is vast in time. The James Webb Telescope is better than any other telescope 100 times, and it has shown us how stars and galaxies evolve, revealing that there is more to the cosmic story than just static objects. We see light that has taken billions of years to reach us, carrying information about the changing nature of space itself. The light we witness today is an echo of the past, and each photon tells a tale of cosmic events long gone. This revelation is a stark reminder that what we see is only a fragment of the full story, leaving us with the question of what is still hidden in the unseen expanse of space. As we peer further into the cosmos, the James Webb Telescope has prompted scientists and researchers to rethink what they know about the very nature of the universe. Space may not just be infinite in size, but could also be infinite in its potential. The discoveries made by the telescope suggest that our universe is made up of trillions of stars, and may be part of a greater, boundless reality, possibly hinting at the existence of other dimensions or realms we cannot see. This idea challenges the way we think about our place in the cosmos and forces us to consider the possibility that there is more beyond our observable universe, something that stretches far beyond our comprehension. The thought that our universe could be just one of many, each with its own set of rules, opens up a realm of possibilities that defies our understanding of physics, space, and existence. The sheer scale and complexity of space, as revealed by the James Webb Telescope, prompt us to reconsider the concept of time. We think of time as linear, a straightforward sequence from past to present to future, but space and time in the universe are intertwined in ways that go beyond our conventional understanding. James Webb Telescope's observations show that events in the universe don't simply happen in a straight line. They are part of an intricate dance of cosmic movements and interactions. This challenges us to question what time truly is. Is it a constant, or just a perception shaped by our limited understanding? The telescope's revelations force us to expand our grasp of how time and space relate, hinting that they might not be as separate as we once believed. James Webb's revelations about space, time, and existence, including its findings on Proxima b, challenge our understanding of the universe and raise the question, what other hidden worlds might be out there? A breakthrough discovery of Proxima b. The discovery of Proxima b, the exoplanet that orbits our closest stellar neighbor, Proxima Centauri, was a groundbreaking moment in the search for potentially habitable worlds. While the existence of this exoplanet has been known for years, the James Webb Space Telescope has elevated our understanding of what this mysterious world is like. With its advanced capabilities, the James Webb Telescope has allowed scientists to peer deeper into the characteristics of Proxima b, and what it reveals could reshape our thoughts on where life might exist in the universe. Proxima b is located about 4.24 light-years away from Earth, making it the closest known exoplanet to our solar system. Orbiting within the so-called habitable zone of Proxima Centauri, it is at a distance where liquid water could potentially exist on its surface, a key ingredient for life as we know it. However, the journey to uncovering the true nature of Proxima b has been complicated. Observations from older telescopes and research suggested that this planet could be rocky and Earth-like, but there were also fears it might be a hostile, barren world affected by intense solar flares from its red dwarf star. James Webb Telescope's sophisticated technology and sensitive instruments have opened new windows into studying this planet. Unlike its predecessors, the James Webb Telescope can observe distant exoplanets in unprecedented detail, offering scientists a clearer view of their atmospheres and surface conditions. By examining the light that filters through Proxima's atmosphere as it transits in front of its host star, the James Webb Telescope can determine the composition and density of its atmosphere. This is where things start to get intriguing, especially in understanding whether Proxima b might actually be able to support life. What the James Webb Telescope has uncovered so far is both surprising and puzzling. For one, its findings have provided hints that Proxima b might have an atmosphere with gases that are crucial for life, such as water vapor and possibly even carbon dioxide. This doesn't mean that Proxima b is a second Earth, but it does suggest that its atmosphere has features that make it worth studying. If the presence of these gases is confirmed, it could signify that Proxima b has conditions where life could, in theory, exist, or at least survive in some form. The discovery would be a major step forward in understanding the true diversity of planets that could potentially host life. Red dwarfs, small and long-lived stars, make up at least 70% of the universe's stars. When the last star dies, the universe will go dark, possibly ending with a red dwarf. These stars may be humanity's last refuge, and they're also prime candidates in the search for alien life. Furthermore, the question of habitability is deeply tied to Proxima's orbital relationship with its host star. Because it's so close to Proxima Centauri, the planet likely experiences what is called tidal locking, where one side of the planet always faces the star. This means one side would be perpetually in daylight, likely very hot, while the other would be in a constant state of darkness, potentially freezing. Such extreme temperature differences could make the planet a harsh environment. However, recent observations suggest that if Proxima b does have an atmosphere, it could help distribute heat more evenly, potentially creating areas that are more stable and possibly suitable for life. The James Webb Telescope's continued exploration of Proxima b promises to push the boundaries of our understanding further. With each new piece of data, we get a clearer picture of this distant world and how it compares to Earth. If not, the search will continue for a world that has the right conditions. Thanks for watching. Don't forget to like, subscribe, and stay tuned for more amazing discoveries from the universe. Until next time, keep looking up.